So this is lesson 6.6. And in this lesson, we're going to talk about the properties, the definition and the properties of trapezoids and kites. So a trapezoid is a quadrilateral, means it has 4 sides, with exactly 1 pair of parallel sides. So we only have 1 pair of parallel sides. Those parallel sides are called the bases. Now, the angles that are formed at each base are called base angles. So this is a base angle here and here, and this is a base angle here and here. The non-parallel sides are called legs of a trapezoid. Write these in your note guide. Do you have that? Okay, just watch then. Everybody have that? So trapezoid, it has exactly 1 pair of parallel sides. So obviously it's not a parallelogram because parallelograms have 2 pairs of parallel sides. Now isosceles trapezoids are trapezoids that have congruent legs. So the legs in an isosceles trapezoid are congruent. And those are fun to work with. So some properties of an isosceles trapezoid would be, if a trapezoid is isosceles, then each pair of base angles is congruent. So in other words, if this was 120, this would be 120. And we have parallel lines here. So same side interior angles are supplementary. So this would be 60, which would mean this would be 60. So the base angles, both pairs are congruent. There we go. Okay, I'll just give you a second to kind of get caught up here. All right, number 2 says if a trapezoid has 1 pair of congruent base angles, then it's isosceles. So if you know that you have a trapezoid, meaning these sides, these bases are parallel, and if what you know is that you have 1 set of base angles congruent, well, that tells you that it has to be isosceles, meaning that the legs are congruent. And lastly, a trapezoid is isosceles if and only if the diagonals are congruent. So because it's if and only if, it means you can read it both ways. If the diagonals of a trapezoid are congruent, then it's isosceles. Or if a trapezoid is isosceles, then the diagonals are congruent. So congruent diagonals happen with a rectangle, with a square, and also with a trapezoid. All right, here's a good problem. It says the stone above the arch in the diagram is an isosceles trapezoid. Find the measure of angle K, M, and J. So it's an isosceles trapezoid. So what that means is the base angles are congruent. So if this is 85, this is 85. You can mark that in right away. And then here's the thing. There's a few different ways you could do a problem like this. But basically, we have parallel lines. And so same side interior angles are supplementary. So take 180 minus 85. And you get 95. So this angle has to be 95. And these two are the same. So this one is 95. So that's how you would do that problem. Okay, this is a good one. It says the second ring of a paper fan shown at the right consists of 20 congruent isosceles trapezoids that appear to form circles. What are the measures of the base angles of these trapezoids? So we want to know what x is. Now realize that this one and this one are the same. And then these two are the same. Those are called base angles. We're going to look at this a couple different ways. We're looking at the trapezoid for sure. But in order to figure out what these angles are, we're also going to look at the whole triangle. Okay? Now, angle 1, we have to start by figuring out what's the measure of angle 1. Does anybody know how you could figure out the measure of angle 1? Okay, yes. In a circle, there are 360 degrees, okay? And this is 1/20th of it. So we take 360 divided by 20, which is 18. So this angle right here is 18 degrees. So 18 degrees. And then in a triangle, remember, this angle, the three angles, this one and this one, all three of them add up to 180. So we would take 180 minus 18, that would be 162. And so what's left over? These two here and here have to equal 162. So we would divide by 2, and you would get 81. So this is 81, and this is 81, so x equals 81. And then remember that these two angles here and here have to equal 180. So take 180 minus 81, and you get 99. So that one's 99. Make sense? Okay, a new vocabulary word. The midsegment of a trapezoid is the segment that connects the midpoints of its legs. So these are the legs, and here's a midpoint, and here's a midpoint of each segment. So if you connect the two, that is called a midsegment. Now, the midsegment has some fun properties. First of all, it is going to end up being parallel to each base. So these are parallel, which means, and that is parallel also. And it is half of the sum of the lengths of the bases. So here's the thing. Let's say this is 4 and this is 8. So what you do is you take the sum of the bases, so you take 8 plus 4, add those together, and you divide it by 2. So that's 12 over 2, and you get 6. That is the length of the midsegment. So you add the bases, divide by 2. All right, so what would it be? Look at this problem. What would be the length of MN if it's a mid-segment, which means this is a midpoint and this is a midpoint? Does anybody online know this? Not quite. You add the bases together. So 12 plus 28, what does that equal? 30, 40. And then you divide it in half. So it's 20, which should make sense. From 12 to 20 is 8 units, and from 20 to 8 is 8 units. So it's right in the middle. Add the bases, divide by 2. Now this one's different. We're missing a base, but we know the midsegment. So use your formula where you add the bases and divide by 2. And what it's going to equal, we're going to set up an equation, is the midsegment, which is 37. Now we have an equation to share. We're going to multiply both sides by 2. And then you have x plus 40 equals 74. And if we subtract 40, x equals 34. So from 34 to 37 is 3 units, and then from 37 to 40 is 3 units. You know, another thing you could do with a problem like this when you have numbers is just say, how far is it from 37 to 40? It's 3 units. So then take 37 minus 3 to get this one up here. So that would work too when you have the numbers. You have to understand the formula, though, when you start doing algebraic problems with that. Okay, so those are trapezoids. Exactly one pair of sides is parallel. Next, we're going to talk about a kite. A kite is a quadrilateral that has 2 pairs of consecutive congruent sides. So 2 sides that are next to each other are congruent. So like here is a pair of congruent sides, and then here is a pair of congruent sides. But opposite sides are not congruent. All right, if a quadrilateral is a kite, then the diagonals are perpendicular. So in a rhombus and in a square, the diagonals are perpendicular, and also in a kite, you have perpendicular diagonals. And then if a quadrilateral is a kite, then exactly one pair of opposite angles is congruent. So the angles that are congruent are the ones that are between the non-congruent sides. So where the 2 sides that are not congruent come together, it's those angles, and the ones that are across from each other are congruent. Now another one, kites are fun. Another theorem, and it's not written here, but it's true, is that these other angles here get bisected. And the reason for that can be proven by using, let's see, HL to show that you have congruent triangles. And then you would know corresponding parts are congruent. All right, let's do some problems with this. So it says, find the measure of angle D in the kite shown at the right. Well, first of all, we know 2 of the angles. And we know that angle D and angle F are congruent. So what we're going to do is figure out, like, what should they all add up to? So if you don't remember, you can use the formula. The sum of interior angles is n minus 2 times 180. So that would be 2 times 180, which is 360. So all 4 angles should add up to 360. So then take what we know, 124 plus 80, that's 204. So from 360, subtract 204. So that is what, 156? So these 2 together have to be 156. So we take 156 divided by 2, and we get 78. Those are both each 78. So the measure of angle D is equal to 78. Okay, next, quadrilateral DEFG is a kite. What are the measures of angle 1, 2, and 3? So first of all, when you have a problem like this, just fill in all the angles that you know. So if this is 52, remember I said these are bisected? This would be 52. These are both 52. And then we learned, so the measure of angle 1, measure angle 2, measure angle 3. So angle 3 is 52. And then remember we said that the diagonals of a kite are perpendicular. So the measure of angle 1 is 90. So then to find the measure of angle 2, we take 90 plus 52 is 142, and we would subtract from 180, which would be 38. Okay. Anyway. All right, so just a summary here, guys. This chapter has been talking about quadrilaterals. Now, if you have a quadrilateral that has no pair of parallel sides, but you have two consecutive sets of consecutive sides that are congruent, it's a kite. If you have only one pair of parallel sides, it's a trapezoid. And when the bases, or excuse me, when the legs are congruent, it's an isosceles trapezoid. Now, when you have two pairs of parallel sides, it's a parallelogram. And if the parallelogram has 4 right angles, it's a rectangle. If the parallelogram has 4 congruent sides, it's a rhombus. And if it has both 4 right angles and 4 congruent sides, then it's a square. All right, so you know what? That is it for this lesson. Thanks for watching.